Last week when we did Pythagoras' theorem, we were always using two sides to find a third side. So it was all about the sides. What we're doing this week, trigonometry, new topic, it's still to do with right angle triangles, but it also involves angles inside those triangles, not just the sides anymore. Okay, so the word trigonometry comes from a Greek word, trigonon, which means triangle, and metron, which means measurement. So we're measuring things in our triangles, if you take that literally. Trigonometry deals with the relationships between sides and angles. Last time we had a weird word, which was hypotenuse, which we're still going to use for trigonometry. We still have a hypotenuse, and it is still the longest side, which is but we also have to give proper names to the other sides as well. So when you find your triangle, lots and lots of triangles in this topic, first of all, you'll look for your right angle here, and you go straight across from that is my hypotenuse, just like Pythagoras' theorem. So that's the easy one to start with. Second thing you want to look for is the angle, because it depends where the angle is as to how we name the other sides. Now, this symbol is called theta. It's a Greek letter. It's basically there's a zero loop in it, and we just use it to represent angles. Okay, so don't freak out by the symbol. That just means the angle. Okay. Now, the names of the sides. Between the right angle and the theta, we call that the adjacent side. So remember, you've got to look for that theta first. Between the theta and the right angle is the adjacent side. Across from the theta, directly across, is the opposite, because it's opposite to the theta. Yeah? Okay, just like we did in Pythagoras' theorem, we're going to practice labeling those things on these triangles. Okay, so first of all, we look for the right angle. And straight across from the right angle is the hypotenuse. I'm just going to say H for hypotenuse. Between the theta and the right angle is the adjacent side, which I'm going to put an A. And directly across from the theta is what was that one called? Opposite. Good. Do you think you can do that? Have a quick try of B. See if you can label the hypotenuse, the adjacent, and the opposite. And triangles get rotated around, so you've got to be careful. You had a chance to do B. Just B, you can do, if you're confident, you can do C and D, but let's just see if you get B right first. Across from the right angle, this is the hypotenuse. Did you get that? Between the right angle and the theta is the adjacent, and that makes this one the opposite. Did you get it right? All right, good. Make sure you try C and D then, please. You've done them as well. Get that one right? Hypotenuse opposite adjacent? Yes, and the last one should be hypotenuse over here, opposite there, adjacent there. Great. If you can do that, we are a very good way along to getting into trigonometry. Okay. Now, trigonometry has 3 rules that we are going to be learning pretty much one at a time. We're going to be focusing on sine mostly today, but I want to show you them all on the calculator first. There is a rule for sine, there's a rule for cos, and there's a rule for tan. Now, sorry, I apologise that these symbols in here, they should be thetas, not q's. Yours says theta. So I'll just fix those quickly. Theta and theta. So there's the 3 rules. They're pretty much the only 3 rules that you need to know for trigonometry. We're going to learn to hear that all. Now, when you use sine, And we do pronounce it sine because the full word is spelled S-I-N-E. It does look like skin, but it's out a bit, but it's correct pronunciation. It involves the opposite side of the apostrophe sign. So you look at those, make sure which side you have, and those will be your sign. If we have the adjacent side and the apostrophe side, we're going to be using cos. And if we have the opposite side and the adjacent side, then we use the minus 10. But all depends on which side we have as to whether we use sine, cos, or tan. To help you remember that, we have a little thing which is stop the colour. Often get people right at the top of their page and they're doing the mixed questions. Because we solve sine is often overlapping. Cos will check, everyone I've got and tan is over check. That's how you remember the three formulas. And it was written here at the top of the page as well. Stoka is a very helpful way for memorizing the three trig functions. Okay, there is a button on your calculator that looks like this, which is going to help us to enter angles into our calculator. So let me bring it up. Here's my calculator. And it is this one here. Button, so it's floating around. But correct name is second button. Just like when you're measuring lengths, we can measure lengths in kilometres, we can measure them in metres or centimetres. We have different size measurements for lengths, don't we? There is actually different size measurements for angles. We're used to working in degrees, and probably 95% of the time this year, we will still just be working in degrees. When you do the topic again into year 10, we'll do more and more of these other degrees in the first one. The one that stands for minutes, down like time, because it is, they work 60, just like that. So degrees, minutes, and the last one is seconds. Yeah, just like that, because they work lots of 60. So there's some here where we have to push that button to pull up and enter the more unusual ones. Okay, let's start with some easier ones. If you're going to do sine of 30, your sine button 10, get out here, sine plus 10. So you press the sine button first, and you just press 30. Now, if it is just degrees, you can get away with just pressing equals after that, and it will do it for you. If you want to practice, you could push the degree button and press equals, but it'll give you the same thing if it's just in degrees. Okay, so it's 0.5 for that first one. Let's try the next one. We want cos of 45. So push your cos button and then press 45 and press equals. Now, most of the ones that you do will be long decimals. So here, 4 decimal places are here. 4. So here's my decimal point. 1, 2, 3, 4. Technically, and then 0 will round up. So it'd be 0.7071. Does that make sense? Let's do another one. You guys get a head start on me. See if you can type in 1020. Okay, just press the equals button. And we want 4 decimal places again. So decimal point, 1, 2, 3, 4 is the 9. Oh, this time's tricky because it's 7 after it. 7 means I have to round up. Rounding a 9 up is never nice. What happens when you round a 9 up? That one goes up. So 0.3640. You still need to make sure that even when this last one you round up, you still have to put the 0 there to show that there are 4 numbers after that. Alright, now we get into some decimal ones here. So we're typing in sine of 25.5. It's still all in degrees. We're not going to degrees in minutes yet, but it's just a decimal. Press equals. There it is again, 4 decimal places. So 1, 2, 3, 4 is up to 5. The 1 will round off. So get rid of all that, and it will be 0.4305. E, type in cos of 72.55 and press equals. What is the answer? For 4 decimal places. Yes, good. Because that last number, the 8, instead of rounded up, you want to pick up. Okay, these last 3, we have got a degree symbol, then a minute symbol. Okay, you've got to use that bubble button. So to type in F, we press 10, 75, press the button, your bubble button, and then 30, press the bubble button again. Now it uses the same symbol, but they both look like degree symbols, but it does mean that one's in degrees and that one's in minutes. Okay, that's it. Press equals. 4 decimal places is the 8667, 1 round down, which is everything else off. 3.8667. Okay, G has degrees, minutes, and seconds. So we go sine 33, press your bubble button. Then 20, press the button again. 30, press the button again. So that we have degrees, minutes, seconds. And press equals. So that will be, someone else want to have a turn in this one? Destiny's done one. What's that to 4 decimal places? Yeah, you do. Give it a go. 3 rounds down. So 5, 4, and 6. One more time. Cos of 20 degrees, 10 minutes. Press equals. 0.9387. Because the 6 gets rounded up to the 7. Okay, so that's just typing stuff into a calculator. We're not really problem solving anything yet, just getting used to the buttons on the calculator. This is what we really want to do. This is what I'll be getting you to do tons of today. All right, so this is our formula. We're just going to be using sine. Just there. Sine theta is opposite over hypotenuse. So all of these triangles that you see down here are going to have an opposite and a hypotenuse side. Okay, so what I want you to do as soon as you see a question is I want you to label the sides that you have. So from my right angle, straight across, there is my hypotenuse. From the 45 degrees, there's my angle, right? 45 degrees is the angle. Across from that is the x, which is the opposite. Now, the adjacent would be sitting over here. I'm doing it because for this question, the adjacent is not, there is no number, there is no letter. So I don't need that. That makes sense. This one and this one have stuff on the sides. Okay, so because the sine is our formula today, I want you to write that down. Sine theta equals opposite over hypotenuse. I just do O over H. O for opposite, H for hypotenuse. That's our first line. Our second line is that we sub in any numbers that we're given in the question. Now, sine is the bottom. The theta is the angle that we've been given. So 45. Sine 45 equals. Okay. Now, the opposite has to be on the top of my function. Where is my opposite? Here. And it is x. So x goes on the top. And my hypotenuse needs to be on the bottom, which is 14. Number 14 is on my hypotenuse. Does that make sense? Okay, so really I have made an equation, not an equation that we're very used to because we're not used to having sines and coses and things in equations, but it is an equation where I want to know what this x is equal to. To get the x by itself, think back to your equations from last year, we do the opposite of that 14 there, which is to times 14 to get rid of that, and we get x equals 14 times by the sine 45. Now, I did the pink part there because that's familiar territory, opposites for our equations. But in trigonometry, you'll probably find that you can go from there to there. The 14 on the bottom just times across to this side. Okay? And then finally, one last thing to do is type that into your calculator. So, calculator time, I'm going to do 14 times sine of 45 and press the equals button. And it says here, I want 1 decimal place. So, 9.9. So, x equals 9.9. Right? So, they are the four substitute, rearrange it, and then a couple of things to think about. Notice that I put the 14 in front of the sine 45. Now, there's a reason I do that is because if you do it the other way around in your calculator, if sine 45 times by the 14, like that, it gives me a very different answer. Because what your calculator thinks is that because I put the 14 at the end, it thinks that all of that is putting the 14 in with my angle, which it shouldn't be. Okay, so that's understanding your calculator. Just if you put it in front, it saves it. Alright, so that 9.9 let's practice that a few more times, and there is one more trick that's going to come up. Let's do the next one. Question 2. Label the sides. We have got from the right angle, the hypotenuse. From my 63 degrees, the x is the opposite. The adjacent is here, but not important because there's nothing there. Okay, so again, opposite. First step, write the formula down. So it's sine theta equals opposite over hypotenuse. Second step, solving numbers of the diagram. My angle is 63. So it's going to be sine 63 equals opposite on the top. So what's the opposite of my diagram? X. Does that make sense? Yeah? So x goes on the top. What is that x? Yeah, so it goes on the bottom. Okay, so I've got the first 2 steps. The third step, remember, is to rearrange. I need to times that 19 over to this side. So I'm going to go straight to x equals 19 times the sine of 63. If I haven't make it a little bit shorter for you, because these are quite big questions for you. Does that make sense? Just times that number across the other side. Okay, last bit, type it into your calculator. So it is 19 times sine of 63. For 1 decimal place, it's 16.9. which is the length of x in my triangle. Okay, we're just going to keep going more and more and more. Question 3. The hypotenuse is the 18, and from my 24 degrees here, the x is going to be the opposite. I'm not even going to bother labeling the adjacent this side. We don't need it. It's not there. So let's write our formula down. Sine theta equals opposite over hypotenuse. Second line, sub in your numbers. What is theta this time? 24. Sine 24 equals, what is the opposite? X, the x, and the hypotenuse is the 18. So see in here, opposite is the x, hypotenuse is the 18. That's why we label those first when they cycle in. Third step, rearrange it. Then you can tell me what the rearrangement is. X equals something. X equals. No. We're trying to times this 18 from here. So it's going to be 18 times sine 24. Yeah, so the sine, we're switching the x over the next bit. But really, this 18 is in time with the trigonometry. Yeah, really? Is it making sense? No. Oh, sorry, let me put the time sign in. For all of these type of questions, when you have the 18 on the bottom, all you're going to do is you're going, I'm going to change a different colour here, is going to go, I'm going to times that 18, I'm going to get rid of it from the bottom there, and getting rid of it from here, and getting it to there. Okay, and that's what this is here, 18 times 19. Is that a little bit better? Okay, now that into a calculator. Okay, to one decimal place, 7.3. Okay, question 4. Label the sides. So from the right angle, the x is the hypotenuse. Make sure you label these right. From the 70, across from the 70, this one is the opposite. This is actually a little bit different to the other ones. Can you see that? Because the x is the hypotenuse for the first time. We haven't had that yet. All right, so let's write the formula down. It's sine theta equals opposite over hypotenuse. So sub in the numbers from the diagram. Who wants to have a try? What's the angle, Kobe? So we never use the 90 as the angle, okay? It's always the other one. So we're going to use the 70. So it's sine 70 equals. Okay, which one have I labelled the O? 10. So the 10 has to be on the top because O has to be on the top. 10 over, and the hypotenuse is the x. Look at the other three questions. X top, x is on the top, x is on the top. This is the first one where x is on the bottom. So there really is two different types that we're doing with the sine rule today. Okay? When the x is on the bottom, don't write this down yet because this is the long way. If we were doing this with our equation skills, if you were doing like, how you do opposite of times divide, those kind of things, opposite of plus is minus, remember doing equation solving? If I was trying to use those skills to solve this equation, I would need to times this x across to that side, because I can't have an x on the bottom, and I get x sine, I should put times there for you, sorry, x times sine 70 equals 10. Don't write this down yet, because I'm going to give you a shorter way. Then, to get the x by itself, I take that whole sine 70 and I need to divide by it. The sign is just a number, it's just an operator. And what you end up with is 10 divided by sine of 70. But that was quite a few steps that I had to do to get there. So this is your shortcut. I'm going to get rid of all that pink. This is the shortcut. To get the x by itself, when the x is on the bottom, so if x is on the bottom, the x and the sine 70 switch. Okay, so the x is going to come on here, and the sine 70 is going to go on the bottom of that fraction. So it's 10 over sine 70. Is that a nice shortcut? X on the bottom, switch places. X on the top, they're the two. Okay? Fourth step, in. You have to be a little bit careful typing fraction ones in, because if you do this, you go fraction 10 over sine 70 and you press equals. The reason it does that is because I didn't close the bracket. When there's that bracket, when you're timing it doesn't seem to care, but you press equals now and it's about knowing your calculator. Which is what we do. What is 10.6? So that's equal to 10.6. Cool. All right, let's do the next one. Question 5. Label the sides. Across from the right angle is the hypotenuse. Across from the 74 degrees is the opposite. The 10 is going to be the opposite. All right, write the formula down. Sine theta equals opposite over hypotenuse. Okay, then sub in. Ashley, do you want to tell me what it is when I sub it in? Sine what? What's the angle? 4, yep, 74 equals, what's the opposite? Yep, over x, good. Great, now x is on the bottom, like this one. So our shortcut is if x is on the bottom, which places? So x equals 10 over sine 74. And then type in the calculator. And remember to close that bracket so it doesn't give you a math error. So 10 over sine 74, close the bracket, equals 10.4. All right. I want to see if you can get one of these started on your own. Can you try to label 6, write your formula down and sub into it? See how far you can go. It's a bit more room when this page is a bit squishy, isn't it? 7 and 8 can go together. Has everyone managed to label their triangle? Yeah. Yeah. So you should have your sine theta x opposite over hypotenuse written down, and then try to sub the numbers in. There you go. Yeah. Good. Okay, so I got sine 49 equals 15 over x. Yeah, that's me. Do you get it? Do you get to that point? Yeah. Oh, you finished it. You get going. Cool. Good. So the X is on the bottom. So for the rest of us to finish this off, if X is on the bottom, switch places. X comes over to the left, and it'll be 15 over sine 49. Okay, so type that into your calculator. 15. Whoop, I just disappeared my calculator. Come back, calculator. 15 over sine 49, close the bracket, equals, what is that? 19 point. 19.9, good. Okay, let's see if we can do the last two. See if you can label question 7. Be careful again, because we're going to switch back to the first. Yeah. Oh, it's on the bottom, just on the last one. So label it. Yeah, see if you can go the whole way. If you can go the whole way, that means you're ready to do the exercise, which is great. Please, and see if you can sub into the formula. Okay, so it should be sine theta equals opposite over hypotenuse. Sub in the numbers from your diagram. The 35 degrees is the theta. The opposite is the 16, and the hypotenuse is the x. The mid. X, that should be an x. Right, x is on the bottom, which means switch places. X comes over to the left, and it's 16 over sine 35. And type that into your calculator. To one decimal place, it is 27.9 again. Okay, last one for the page. Label it. We have our hypotenuse is the x. 41 degrees is my angle, which means that the 13 is opposite. So write down the formula. Sine theta equals O over H. Sub in sine 41 equals, the opposite is the 13, the hypotenuse is the x. X is on the bottom, so we switch places. X equals 13 over sine 41. Oops. 19.1. Okay, so it is quite unusual. If they haven't done anything like this before, I know this is a very unusual step that we're taking here, some very new content. But if you can get the hang of it with sine today, when we do it with cos and then we do it with tan, it is a very, very similar process. Okay, so be encouraged by that. You're going to start here on page 24 and see how many of these questions that you can get done. Remembering to label so that you know when that X is on the top and when it's on the bottom. Now,